Hi, this is our senior design control system. This system will control our linear piston, the pressure inputs to each side. The two relays on the left will be controlling one side of the piston, and the two on the right will be controlling the other. And it goes in order from pressurized to evacuation to pressurized to evacuation. And that makes sense for people who understand our senior design project. The relays are controlled by transistors, which are controlled then by the Arduino in this simple circuit, which you should be able to see now. These solenoid valves that we'll be using will be in place of the LEDs, and in the power source for the solenoid valves will be this power source, which is a 12 volt AC to DC converter. So the relays should have enough power, or rated high enough to handle that type of current, so we shouldn't have any issues on the electrical side. You can see I improvised on the diodes with LEDs, light emitting diodes, so they have the same effect with the resistor to make sure that they're rated high enough. So this is running the system at 1 hertz. 1 hertz. If we bump it up to 2, that looks like this. So it takes, there are 2 cycles per second, and 1 cycle is this one turning on. So you can think of it as this one turns off, and then this one turns on, and then this one turns back on, and then that one turns off. That's 2 cycles, and that's happening every second. So we'll bump it up to 5. And it starts to get kind of ridiculous, but not for the control system, hopefully. And I'll show you 10 and then 20, and we'll call it good. Here's 10 hertz. And here's 20 hertz. And it's going to be very hard to see. You may even only see one LED lighting up, but you can definitely hear the solenoid valves, the relays working. So I'll put that back down to 1 so we don't mess up our relays. There's a 20 milliseconds assumption for each solenoid valve. The opening and closing process should take a maximum of 20 milliseconds, and we're going off that assumption. We'll find out how fast we're able to physically run the system mathematically before we test it physically. So currently this is what we have as far as the control system. And just a quick peek at the Arduino, the wiring. This chip is actually not connected at all, so please ignore it. Thank you. That's what we got.